Nikta Fakhri is here right now with me, the Early Career Award recipient for Soft Matter Research. First, let me congratulate you for the award.
Thank you so much, and thank you for having me.
Tell us a little bit more about your work.
Yep, so like many biophysicists, we are fascinated by the fact that there is something different about being alive, and we would like to know what that is, in the same way that we know what it means for a collection of atoms to be solid and for a collection of electrons to be superconducting. And to discover these laws, we do not always keep track of all the electrons and protons. We are always looking for important variables and key degrees of freedom. And once we know what these key variables are, we combine them into what is called an order parameter, which is the quantification of the emergent phenomena. And of course, this approach has been very powerful in physics of equilibrium systems, the physics of all the materials that are around us. However, life, by definition, is out of equilibrium. There is this famous saying that if you are at equilibrium, you're dead. So the question is, can we come up with principles that we can use to describe physics of non-equilibrium systems, such as physics of life? And this is a challenge that my group have set out to address. And to do so, we're experimentalists, so we develop experimental tools to observe non-equilibrium living systems. And then we come up with basically data analysis frameworks to define this order parameter fields. And then we, of course, collaborate with my theory colleagues to develop theoretical frameworks that have a predictive power. So this is, in a nutshell, what
in a nutshell, very deep research. Where do you see the research being applied, either for other research projects or even in everyday life?
I think it's a very exciting area of research. It actually falls under the umbrella of a very exciting research field called active matter, which is basically the idea that these active matter systems are many interacting parts that are that individually consuming energy and collectively generating motion and stress. And of course, it can describe physics of many systems, such as a flock of birds, all the way to a single cell.
How long have you been doing this research, and how does it feel for you to be recognized for it? Because you spend such a great deal of time on really complicated topics.
So I started kind of moving in this direction when as a postdoc. And of course, when I started my group at MIT, we really tried to delve into this question. And of course, I'm truly honored to be recognized by this award. It's obviously not just me, it's a wonderful group of students that I have at MIT, but also colleagues and collaborators all around the globe.
Well, it's you who's being recognized today, and we say congratulations.
Thank you.
Thank you for being here.
Thanks.